Quick, graph y equals the natural log of the quantity 1/2 x by hand 2 different ways. It is highly recommended that you watch the video how to graph y equals f of the quantity k times x before watching this video. You will need graph paper, or you can download this PDF and print it and press pause as needed anytime during the video. The first way is with the natural log of x dance. Y equals the natural log of x has an asymptote at x equals 0, or the y-axis, and the 1/2 in the argument has no effect on this asymptote. So we'll go ahead and draw in x equals 0, the y-axis. The origin is unchanged by the coefficient 1/2 in the argument, so we're going to plot all points relative to the origin, 0, 0. Also recall that the coefficient k equals 1/2 is inversely proportional to the horizontal dilation factor, the reciprocal of k. That is, multiply each x value by the reciprocal of k, which is 2. We do need to know these powers of 2. Okay, we're going to need those for both the e to the x and natural log of x graphs. So normally we'd go right e up 1, but in this case it's and also recall that the natural log and e to the x functions are inverses of each other. You just interchange the x and y coordinates. So instead of right e up 1, it's going to be right 2 times e up 1, or 5.4 up 1. Next we'd go right e squared up 2, but in this case it's going to be 2e squared up 2, which is about 14.8 up 2. Right e to the 0 up 0. In this case, it's going to be right 2 times e to the 0, which is 2 up 0, 2 comma 0. Right e to the negative 1 down 1, but this time it's going to be 2 times e to the negative 1, which is 0.8 down 1. And then right e to the negative 2 down 2 will become 2e to the negative 2, which is about 0.28 down 2. Connect the points and compare it to the parent function, and we can see that from blue to green this is a horizontal stretch. Second way, using a table. This is our natural log table. Remember, if you interchange these, you have the e to the x table. And again, we need to recall the powers of e we're supposed to know. Since k equals 1/2 inside that argument, the horizontal dilation factor is the reciprocal of 1/2, which is 2. So we keep the y coordinates the same, but multiply each x coordinate by the reciprocal of k, which again is 2. So 7.4 times 2 is 14.8. So we'll plot 14.8, comma 2. Double the x coordinate here, 5.4, comma 1. Go ahead and finish these 3 values here, these 3 points, plot them, press pause, and continue when you're ready. One times 2 is 2, 2 comma 0. 0.4 double to 0.8 comma negative 1. And 2 times 0.14, 0.28 comma negative 2. Draw the asymptote, the y-axis. Connect the points. And compare it to the parent function, and again from blue to green it is a horizontal stretch. Now you try one. Graph y equals the natural log of the quantity 1/3 x. Use either method or both for the practice. Press pause to do this and then resume when you're finished to check your answer. And here is the answer. Compared to the parent function, it is a horizontal stretch.